Hello, my name is Mac. My pronouns are he, him, and I am a game programming major here at Columbia College, Chicago. This video will provide an overview of the basic data types in C# and how we can work with them. First, I will explain how a computer physically stores data. Then, I will get into how we can work with different data types in code. For this video, I will be using C# to demonstrate, but everything covered should ring true across any programming language. However, syntax may vary slightly. I'm sure you have heard of the concept of bytes before. For example, when you buy a flash drive with 16 gigabytes, that means it contains roughly 16 billion bytes worth of data storage. Each byte contains 8 bits, which are the stereotypical zeros and ones associated with computers. A bit is an electronic component called a transistor that stores an electrical charge, or no electrical charge. The computer reads a charge as a 1 and no charge as a 0. When we create a data type, for example, an integer of 0, we are basically looking at a few bits of computer memory and setting them all to have no charge. If we set it to be 6, it will store this as 110. The way these zeros and ones are read is through binary. If you are interested in diving deeper into that particular topic, I will leave a link in the description. Each data type requires a unique number of bits to store itself. For example, an integer in C# by default is 32 bits. So whenever we declare an integer, the computer is setting aside 32 bits in its memory for that integer. By default, all these values are set to 0, so all the transistors are set to have no charge. A variable is basically some data that varies throughout the lifetime of our program. Every variable contains a data type, whether that is one we create like a class, or one of the fundamental data types we are covering in this video. In C#, the syntax for declaring a variable is data type, variable name, and value. The data type tells the computer how much space to set aside and how to interpret the data that is stored in that memory. So if we say int, the computer knows to set aside 32 bits in its memory and read it as a whole number. The variable name, which comes after the data type, is how we as the programmer talk about that specific integer and reference it later in our code. Finally, the value is the value that we put in those bits of memory when the program initially runs. Now I will get into all the basic data types and how they function. The simplest data type is a bool. It is simply a 0 or 1, a true or false. When giving bools a variable name, it is generally good practice to pick something that, when asked like a question, can be answered with true or false. I gave this bool the name isRecording. If asked this like a question, is the computer recording? A response could be true or false and sounds like a valid answer. The data we have used as an example so far throughout this video is an integer or int. It cannot store decimal values. The next numerical data type is a float, which, unlike the int, can hold decimal values, whereas the int can only hold whole number values. Whenever we are working with a float, we have to put an F after the number, so the compiler knows to read this as a float. A larger version of the float is the double, which basically just holds more digits if you need more precise calculations. The reason the float needs an F is because by default, any non-whole number value is interpreted as a double in C#. The F explicitly says, hey, read this as a float. Now you may be wondering why we have two data types that essentially do the same thing. Well, this is because memory can be a very valuable resource when working with computers. Using a double may not be necessary in some cases, as that much accuracy would not be needed for smaller decimal numbers. However, more decimal places can help when working on very precise calculations. So it's really about finding the best tool for the job as a programmer. There are 8 and 16-bit ints as well for this same reason. As a beginning programmer, don't worry too much about the memory usage of the type you are using. Modern computers have lots of memory in comparison to the small programs we may write. However, it is useful to know why these different types exist as you encounter them down the road. The next data type is a character, like a letter or symbol that is on our keyboard. In C#, we declare it using char. When we see words on our computer screen, like this code right here, it is stored as a string, which can be thought of like a string of characters that form a word. In the computer's memory, you can think of this data type being represented as a bunch of char variables stored consecutively. So those are the basic data types that make up every program on your computer. Everything from the color values of pixels on your screen, which are usually stored as ints, to the audio of my voice that you are hearing right now, which is generally stored as a float from -1 to 1. This overview of the uses and properties of basic data types should hopefully have provided you with a better understanding of what data types are in relation to physical hardware, as well as some of the things to keep in mind when using them. If there's any information that wasn't covered here that you'd like to know, please leave it in the comments below. Check out our website and other videos for more helpful tutorials. Visit iam.colum.edu for department information, events, and resources. This was Mac from IAM at Columbia College Chicago. We hope you have a good day.